Hi everybody, this is another video of Mir series, Mir interpretation of a spin, explaining very clearly what's the angular momentum and what's the spin exactly in detail. As I said before, a spin is charge of variation. This is particle. At some stage is low in energy and it goes high energy. It goes low, it goes high. So what we call here spin up, spin down, spin up, and so on. That's the spin. At the same time, it has slight rotation, whatever direction it is, some in the opposite direction, which is more put towards the helicity, not the magnetic moment. And then you want to know about how to address photons spin or electrons spin, which is different number. So this is spin 1. This is a spin half. I made a mistake here in writing. So a spin half, as it cycles the charge, low, high, for each cycle it just turns half a turn. So you need 2 cycles to get the full turn. This is a spin half, like electron or positron. And the spin 1 would be turns faster compared to the change of the charge. So when it is spin down, it's half a turn already done. To spin up is done the full turn, back to the, in 1 cycle, back to the original state. So you're dealing with 2 frequencies here. One frequency is about the variation of charge, which if you want to draw it, start from 0, low. For electron, I'll put it for you to get familiar. That's the low, that would be low here, coming high here, and low here, and high here. Low, high, low, high. That's the variation, follows the sine wave. And for the angular momentum, you have the lambda. Here the lambda would be from here to here. But the angular momentum would be 2 cycles from here to here. Lambda. And this lambda. With the spin 1, let's do the photon. Case of photon would have had negative, positive, a bit complicated. With photon, I can't draw it right now. This is because it consists of positive and negative. So it goes positive and negative region. Let's say particle with the spin 1, apart from photon, which goes in, it's got charge, which we don't have probably. We go positive region now, positive charge. So it starts from here, high, low, low, high. Hopefully next time I will have animation. It should come here. And the angular frequency would be each cycle. You got this lambda for spin, and same with angular frequency. Same from here to here. Now you can check, double check with the current version of physics if that's the case. In the spin one, the angular, the lambda is same for spin and the angular momentum, angular frequency or angular momentum, or is not. And for half a spin, the angular momentum has a twice lambda, twice size of lambda. Okay, thank you very much. See you with the next video.